Here's an electric circuit to help us test out our knowledge of circuit theory. It has a 12 volt battery, an ammeter, and just 3 resistors, an 8 ohm and 2 4 ohm resistors in parallel. One of the 4 ohm resistors in the branch has a switch in series with it which can be placed on and off. And we're asked to find what will be the current and voltages when the switch is open and closed. Well, let's begin with the switch being open. When the switch is open, then effectively what we have is we've got no resistor there. That resistor is blocked off. When the switch is open, the resistor is blocked off. So the circuit reduces to just a simple circuit with 12 volts, an 8 ohm and a 4 ohm in parallel. So we can work out the current from the circuit if we know the total resistance. The total resistance of that series circuit is quite simple. It's the first resistor plus the second resistor. And that's going to give us 8 ohms plus 4 ohms, which is 12 ohms. Now we know the total resistance of the circuit, we can work out the current which is flowing round that circuit. And we use Ohm's law, rearrange it to give the current I in the circuit equals the voltage of the battery divided by the total resistance of the circuit. So we're going to have 12 volts divided by 12 ohms, and that's going to give us a current of 1.0 amps. So we're going to have 1 amp flowing through this circuit. What will be the potential differences across each resistor? Well, we can look at them in turn. The 8 ohm resistor, we can say all our characters V, I and R. We know the current going round the circuit is 1.0 amps. We know the resistance of it is going to be 8 ohms. So therefore we can just simply say V equals IR. So we're going to have 1 times 8 is going to give us 8 volts. So we're going to get a potential difference across AB, the 8 ohm resistor, of 8 volts. We don't have to do the second calculation for the 4 ohm resistor because we know that the total potential differences round the circuit dropped across each resistor should add up to give us the potential difference of the voltage across the battery. So this will be 4 volts in here. So that's us done the basic circuit. In this situation, 1 amp flowing, 8 volts and 4 volts. We can test out by looking at the PHET site, and here it is here. And you can see identical resistors. If I show the values of it, 4 ohms, 8 ohms, 4 ohms, and we have a current flowing in the circuit of 1 amp. What about the potential difference? Well, we take our voltmeter across here, and our circuit theory predicted 8 volts, and 8 volts is what we get. What about the potential difference across the branch? Potential difference across the branch with the switch open will give us 4 volts. So our circuit theory proves everything is correct. Now let's use our circuit theory to work out the values in the circuit when we close switch S. When we close switch S, we've effectively got this situation here. We have 2 4 ohm resistors in parallel. So remember our circuit theory, work out the parallel part of the circuit first. So we've got 2 4 ohm resistors in the parallel. We could use a formula again. 1 upon RT is equal to 1 upon R1 plus 1 upon R2. So 1 upon RT for resistance between B and C is going to be 1 upon 4 ohms plus 1 upon 4 ohms. And in fractions, that's going to be equal to 2 over 4. Therefore, the total resistance is going to be equal to 4 over 2, which is going to be equal to 2 ohms. Now, we could have done that very quickly because we know the rule of thumb that when you have 2 identical resistor values in parallel, then the combined resistance is going to be half that value. So those 2 resistors can be replaced with a 2 ohm resistor. So we bring over that, replace that parallel branches with 2 ohms. So now our circuit looks like that. So we have an 8 ohm in series with a 2 ohm resistor. Now what will be the current flowing in the circuit now? Well, the combined resistance of the circuit, the total resistance of the circuit, RT, that's the new total resistance of the circuit, is going to be 10 ohms. Therefore, the current flowing in the circuit, according to Ohm's law rearranged, is going to be 12 volts divided by 10 ohms, is going to give you 1.2 amps. So the current flowing in the circuit is 1.2 amps now. So the potential difference across the 8 ohm resistor, well, once again we can put down all our labels V, I and R. We know the resistance is 8 ohms. We know the current flowing in the circuit is now changed to 1.2 amps. Therefore the potential difference across that resistor is going to turn out to be 8 times 1.2, which is going to be 9.6 volts. So we have 9.6 volts dropped across the resistor. So by closing that switch, we have increased the current flowing in the circuit. Therefore the 8 ohm resistor is going to take a bigger share of the voltage of the battery. So what will be the potential difference across the 2 ohm resistor, which is effectively the potential difference across those two resistors in parallel? So 9.6 volts from the 12 volts, so 12 take away 9 is going to leave you with 3, and take away the 0.6, we have 2.4 volts across the 2 ohm resistor. We could have worked it out with our circuit theory, V, I and R. The current flowing in the circuit is 1.2 amps through that resistor, and we know that the resistance is 2 ohms, and therefore we can see V equals I times R is going to give you a value of 2.4 volts. So we have 2.4 volts across B and C. So by closing that switch, we have changed the current in the circuit has increased. The circuit resistance has decreased, the current has increased, and the potential difference across the 8 ohm resistor has increased as well. Let's take a look at our PHET simulation for this circuit, and there it is there. So you can see we have an 8 ohm and 4 ohm and 4 ohm are now connected together to be a parallel circuit. The current is 1.20 amps, and our voltage, if we go and measure our voltage now across the 8 ohm resistor, that's correct, it's 9.6 volts, which should leave that 2.4 volts across the parallel part of the circuit. So we go across here, we have correctly 2.40 volts. And that means that the potential difference across the top resistor will be identical. Remember, in a parallel part of the circuit, the potential difference across each branch of the parallel part is exactly the same. So the potential difference across the 4 ohm resistor would be 2.40 volts, and the potential difference across the bottom resistor would be exactly the same, 2.40 volts. Which must mean that the current flowing through the 4 ohm resistor is 0.6 amps, and the current flowing through the bottom 4 ohm resistor is 0.6 amps as well, because both resistors take the equal current. So once again, our circuit theory is proving to be correct.